So good morning students, we will pick up from where we have completed. Okay, till where we have completed. So echo versus reverberation we have completed. I will repeat it again. Echo means single reflection. Okay, so you are speaking, so from your mouth so many waves are coming. If you will focus on one wave, if one wave is hitting and coming back and you are hearing that, this is known as echo. Okay, single time. If it is hitting many times and you will hear many echoes, it is known as reverberation. So reverberation is useful also, and it will be like harmful also. So we will see how many situations are there in which we want to increase it, and how many situations are there in which we want to decrease it. You can see here. So multiple reflection means reverberation. How many uses are there? There are 4 uses. One is we can design instruments, musical instruments, on the basis of this concept. Second is stethoscope design. Third is we can curve the ceiling. Okay, see here we want to increase it, here we want to increase it, here we want to decrease it, here also we want to decrease it. So to increase, to decrease. Now see, we will make it curved, it will be decreased. If it will be straight, it will be increased. You see here, so the straight lines are there, means straight tube is there inside the loudspeaker. You can like think about, you can hear where when some elections are there, so the people are coming to announce, okay, what kind of the promise they want to make to the public. So that way they are keeping this near to their mouth. So from their mouth, one wave is coming, so many waves are coming, because you are so many particles, your energy is hitting so many particles. So on the basis of that, how many waves are coming, so we will focus on one wave. So one wave, you see, it will hit it on this point, then second point, then third point. So it is hitting and it is coming at like an echo. So how many time it is hitting? So how many time it is hitting? It is making one echo. Okay, so you see multiple time it is hitting, so it is reverberation. So you see many echoes you will hear. So all the people who are present in the crowd, they can hear the person's voice. Same is here. So like heart is beating, so the doctor can hear the beat clearly. Now here you see the curved ceiling. Okay. So many people are coming, like sitting here. So we want to decrease the reverberation, means echo we want to decrease. Echo means you can hear many voices, so you don't want to increase it, you want to decrease it, so that only one echo is okay. So one time you will hear that echo, one sound you will hear. So what we will do to decrease it, we will make it curve, we will not make it straight, we will make it curve. So if we will make it curve, you see this wave will hit here and like reflected back one time, this will not hit again. So it will like reflect and then it will hear, that person will hear. You see one time here, and then this is the wall, so it will hear here, it will hit here, and then it will be heard by the person. Okay, so decrease it here also, they will like do the curved, they will cover the ceilings also to curve, curved board, or some like sound proofs are there which will like absorb the extra echo. Okay, you see here curved board, what are there? So the curved kind of the like board, curved kind of the apparatus or instrument, it will be attached at the back of the speaker, so that if extra echoes are coming, so it will absorb it and you will hear only one voice. So here we want to decrease it. If you want to decrease the echo, you will make it curved. Okay, you see here, so multiple reflection will not be there, you need only one reflection. So one reflection will come and it will be like intensity will increase. But if many echoes are there, many time it will be reflected, so you will hear one voice many times, so you don't want to be puzzled. Okay, so you will do in one like one method is you will make the ceiling curved. Second is you will like purchase some of the soundproof curved board. The soundproof board means they are curved board, so you will cover everything in that concert hall, in the music hall, or if you are like if some person is coming, he's playing piano or he's speaking, he's giving the speech, so he won't, everybody will hear his voice clearly, echo should not be there. So only one echo is fine, it will like hit and it will come in back. Or if you want to decrease that one also, they will like cover everything with the soundproof boards. Soundproof walls will be there, so that only one voice should be heard. That is a multiple reflection. Now the next one is, here we will come, the next topic is the speed of sound in different medium. Okay, now see, three type of the mediums are there. Fourth one is vacuum. So when sound is traveling, so it is dependent on two factors only. First is what kind of different mediums are there, and its speed will be affected. And third is temperature. You see, if that we have discussed so many times in chapter 1 also we have discussed. So in solid the particles are they are very closer to each other, so the energy pass will take very less time. So if it will take very less time, then energy will be passed quickly. So in solid it will be highest speed, in liquid medium, and then in gas it will be slowest, because the particles are very far away. Then the second factor is temperature. When you will increase the temperature, what will happen? Its vibration will increase, up and down movement. Okay, that vibration means back and forth movement. Okay, like this. So if your temperature will increase, what are you doing? You are giving extra energy to the particle. Okay, first that particle is having 5 kilojoule, and if you are heating it, what you are doing? You are giving extra 5 to it, so it will become 10. So when it will become 10, means it is like more than its resting. Its potential energy become kinetic energy. Kinetic energy means what? It will move up and down, back and forth. So its speed will increase. So high temperature means speed will increase. Speed of the wave. Now the next topic is application of ultrasound. Now sound type we have already covered. So it can be sonic sound, or sonic sound, ultrasonic sound, or infrasonic sound. Sonic sound means whatever we can hear. Ultrasound and infrasonic we can't hear. Okay, so if the frequency is less than our normal hearing range, that is sonic. If the voice is less than sonic, okay, less than sonic, it is known as infrasonic. If it is greater than sonic, then it is known as ultrasonic. So remember their ranges. Okay, now they are also known as high frequency waves. Infrasonic are known as low frequency waves. Okay, now see, there are so many applications. This is the last topic in your chapter. So many applications are there. This is not in your syllabus. Okay, this is deleted when you see the new NCRT. So it is not there. Sonar. Okay, if you want, then I will explain it later. Now the first is cleaning, second is crack detection, third is echocardiography, fourth is ultrasonography, and fifth is echolocation. So I will explain one by one everything. Now see, cleaning, you can understand that they are high frequency waves, so they will not make a damage. You can't hear that. They will not make a damage. They will high frequency. If high frequency is there, it is having high energy. So with high energy, it will move and it will clear everything, every dust particle. Okay, so this is the apparatus. This is it is present in the science lab also. You can see that. So you will fill, there is a one solution is there. So in the solution you will put any kind of the apparatus is there. Some apparatus parts are there which you cannot every cleaning part, every cleaning apparatus, like you can see the test tube brush. The test tube brush is what? It is suppose this is the test tube, so you can, this is the brush, so you can clean it. You will put it inside and you will clean it. But if its shape is circular, not circular, the spring type, okay, spiral, so you cannot put it inside. So it will be difficult for it to it's a spiral, so you can't clean. You can clean this part, you cannot clean this part. So it's it's spiral. So for cleaning some of the parts which are which shapes are different, so for that we will use the ultrasonic cleaning. So what you will do, you will remove the parts from the machine, put it inside the solution, and then you will pass the ultrasonic waves. So ultrasonic wave being the high energy wave, they will go every part of the tube. Suppose spiral tube is there, and it will clean it. You cannot clean it with the brush. But ultrasonic waves, their energy, no, they are normal energy, so they will hit all the particle, whatever particle, dust particles are there, so they will hit it and they will push it, so it will come out. Next one is crack detection. The same principle like this one. So if any crack is there, what will happen? The ultrasonic waves will hit it and come it back, so you can hear the sound. Okay, that is echo. the reflection is there. So any type of the crack is there, it will be detected by the ultrasonic waves. Next is echocardiography. Cardio means heart, echo means reflection, graphy means echo means one wave will be sent to your heart, okay, then it will like hit it and then hit all the like different parts of the heart, and then it will come back, and then it will be coming as a sound wave, means a signal. You will convert it into a message, and that message will be printed on the graph, means it is in the machine, it will in the machine electrical signal will be converted into the graph, that is known as echocardiography. For like in simple waves, it is a big word, so you can divide it into three parts: echo, cardio and graph. So if you want to see what is present inside your heart, which method is used? Sending the UV rays inside your body. Okay, so UV rays will hit every part, they will be reflected back, echo, and then that graph you will see, and you will find out if any problem is there in the heart. You will compare that image with the normal heart image. Okay, so you see now, that is next one is like ultrasonography. So sonograph means sonograph, graph means that same, that like on the paper the image of your organ. Ultra means ultrasonic waves, ultrasonic waves used to graph your internal body. So echocardiography is used for heart, ultrasonography is used for internal organs, okay, the soft organs inside your body like liver, kidney, intestine. So to detect the abnormalities, means if any problem is there, if any like abnormal growth is there, tumor is there, stone is there, so what will happen? If stone is there, like the crack detection, so if stone is there, the ultrasonic wave will hit it and then come back, and that usually when it is hitting and coming back, the energy will differ, okay, so it will create a different image, okay, so that you will use to detect it. And then if you will detect it, you will see the image, and then you can this is known as image, that graph is known as sonograph. Okay, this question also come, the image that is printed on that film, that you like printer, no, like in printer you will put some paper, and the ink is printing everything. Same the way you will like put some like film, some paper inside, and then you will see it is due to the wave that is coming back, it is like creating the image of that organ, that is known as sonograph. And now the last is echolocation the same way. Bats, they are also sending the ultrasonic waves. Okay, so you see this one, the small one, it is like this, it is sending the wave. What will happen? This wave will hit every part of the every single part of this insect, and then it will create the image inside the mind of the bat. So it can like understand by sending only the echo, like this waves. You cannot send it because you can't hear that, you can't produce these waves, and you can't hear even if the bats are around, you can't hear whatever they are speaking. Why? Because their frequency is higher than your hearing range, you can't hear anything, but they are using in their normal life. So to understand what is the distance, what is the height of the organ of the organism, so they can help, this echolocation, this echo means the reflection of the wave is used to find out the location of the prey, the organism they want to kill. Okay, so the last one is sonar is not in your syllabus. So some questions are also there in your syllabus, in your exercise, which are not there. You need not to do it. So I will explain that also, what you have to leave. Okay. Now the next topic is you just do these two tables. This is a very important to understand what is the difference between two similar concepts. See, intensity and loudness. See, what is intensity? If you are having a speaker, so what kind of the actual volume it is producing? Okay, means some types of like energy molecules it is producing, some waves are producing. So how many waves it is producing, that is known as how many waves, that is like how many waves are there, how many, that type of the energy will be there. Suppose 10 waves are there, so you will see 10 joule of energy is there. So that 10 joule is known as intensity. So how much energy it is producing, that is means how much sound energy it is producing, this is known as intensity. So how you are, what is the response of your ear to that intensity. For example, suppose 10 joule energy is produced by one loudspeaker, and two people are there. One is the old people, like 50 above, okay, 60 above suppose, and second is what, very like young teenager is there, 15 or 16 or 11 or 12 year age, and not age. For example, you see sometimes what happen in normal age also, in the young age also, some ears are not working, like some defect is there from the childhood. So what I am saying, what I want to say here, if 10 joule energy is produced by one source, so two people are there. People number one whose ear are good in condition, all the three part of the ear are in perfect conditions, means external, middle and inner, no problem is there in his ear, so he can hear 10 joule energy. But if second person is there, his ear some damage is there, so what will happen, intensity of that like 10 joule, it will like hit its internal ear very badly, so he can feel the shock out of that. So intensity will be same, but its loudness will be different for two people. So for one person whose ear is good, the intensity of the that sound source, it will be okay. But for second person whose ear are not working properly, the same intensity sound will be very hard for him, his ear will start paining. Okay, so person one will be comfortable, person two will be like he will be under stress. So that is the loudness. So loudness is how your ear are responding to a particular intensity. Now the second one is tone and note. So note is like bigger than tone. So if single frequency is there, that is tone. If more than one frequency is there, it is note. So note is like basically in the music. So it is just like you can understand the echo and reverberation. So echo means single reflection and reverberation means many reflection. So the same way. Now the last one is formula. So you will understand, you will remember this. So many formulas are there in your chapter. So I have consolidated it in one place. So what is the symbol? Now what is the formula? What is the assignment? Okay, so wavelength. This is two formulas are there. V is equal to nu lambda. Then wavelength. The V is equal to nu lambda, from this it is coming. Okay, wavelength. Then SI unit is meter. Amplitude capital A. No formula is there. SI unit meter. Time period capital T. Formula is 1 by nu. And then second frequency nu 1 by T, 1 by second hertz. One another formula is also there which we will use in the exercise. So it is number of oscillation by time. We will see, you can add that in here, because while doing the exercise I just got to know that formula is also used here, so you can add it here. Now next one is loudness. Loudness means what is the height of this wave. Okay, what is the height of crest and what is the height of trough? See, this one is the height is less, so loudness is less. Here the loudness is more. So it is amplitude square. Its SI unit is decibel. If less amplitude is there, it is known as weak sound. More amplitude is there, it is known as loud sound. Next one is pitch. There is no formula. So high frequency is known as sharp sound and low frequency is known as deep sound. So you can understand that by the adolescence. In adolescence, you can see the high frequency sound. It is of male or female? It's of female. Okay, so females are having high frequency. They are producing the high frequency sound, and like male means in teenage. So it is girls' voice. It is boys' voice. So boys are having the deep voice at that time. After some time, it will be normalized, but it is due to the growth of your throat. Okay, your Adam's apple. It is going no. That's why this. Frequency changes there. Sometimes after some time it will be normalized. Next three type of the sound is there: sonic, infrasonic and ultrasonic, that I was discussing there. So you have to understand and you have to remember their frequency. This is very important because this is your frequency. whatever you are speaking, and you can speak and hear this one, that is sounding. So speed of sound, there are 3 situations in which the speed of sound, all the formula you have to learn. See, if distance and time is given and no reflection, normal question is given, then you will apply the same formula that you are using in the motion chapter also. So v is equal to d by t, velocity is equal to distance by time. Now the second one, if reflection is given, so it means it is hitting some surface and coming back. They are, means in the question, the statement of the question, it is given the wave is reflecting somewhere and it is coming back. Then you will use 2d, because 2 times it is reflecting. This distance it is covering in 1 time,